Yeah, so hoping to continue the same levels of engagement, Q&A. Love your questions. I have, similar to Gabriel, picked a few topics and some slides and data points to show as reference if applicable, but really, if this is for you guys, the audience. So ask away and contribute as well. On this one, we don't have a service provider representative, so kind of leave it to you guys, the service providers, to represent yourselves in pushing back on our esteemed but somewhat biased vendors.
Absolutely, we're going to be asking questions that way, right?
Great, yeah, so Joe Masserino, familiar face to the light reading event circuit going back, although his face doesn't change, I don't know what you do, but you never have to update your photo. Joe Masserino, Principal Solutions Architect with Fujitsu, again, longtime participant at our events, in person and virtual, and then Tim Pennell, Senior Director, Product Management, representing Juniper today. So both a great amount of experience in this area, and looking forward to their thoughts and contributions. Also, can you run the clock so I don't get lost? I don't want to keep people away from their lunch hour either. So the topic is on open and disaggregation. This is just one slide to kind of set the stage of everything we're going to talk about. So you know the scope and can ask away and kind of understand where we're coming from. Disaggregation is people think of, I think, a certain thing. We did want it to be broader. So this is all aspects of open and disaggregation as it's specific to the transport network. And thinking it through, there's kind of four main areas you guys can contribute and push back if you think there's others. But the one we focus on quite a bit, or one of them, has been the RAN decomposition, the separation of the front of the RU, the radio unit, distributed and central unit, and the different segmentation that's comes about through that, and the different ways to combine elements, and certainly towards virtual and cloud RAN. Some of this we've already talked about this morning, as well as all of the discussion around Open RAN is I would say, a subset of that particular aspect of open and disaggregation. The other one that gets a lot of attention in past events, and we'll talk about it here, is the vertical disaggregation, which is the white box concept of separating the control plane from the data plane and having white box hardware with a separate service provider's network operating system. Also has gotten a lot of attention. We'll talk about it. But there's actually two other areas that are important, and there are aspects of open, and they kind of all overlap at some point as well. We'll spend a good amount of time talking about pluggable optics, and this Mark's opening presentation and talking about the heat requirements is very relevant here. Pluggable optics are, an aspect of open. You're putting optics into a third-party piece of hardware, whether that's the radio unit or somewhere else in the network. Certainly routers and even optical transport gear is moving much more towards pluggable optics and open ecosystem. So that is a really fertile aspect of transport. We include it under open and disaggregated. We'll talk about that. And then the last one is the open control and management, which, as I said in the opening comments, this was kind of the SDN bucket. We're not going to talk about SDN. SDN is the enabler for open software between the different layers of the network, and really in this case we're going to delve into automation as kind of the avenue there. So those are our four areas. We'll hit on all of them, but please ask questions, and as I said, push our panelists who have enough gray hairs to have taken some pushback in the past, so I think they get the drill. Let's start with the white box concept. And this has also come back, and I appreciate some of the comments even from Ericsson's last presentation, as well as in the opening, have hit on some of this. The impacts of white box and disaggregation on 5G transport, and there's a couple subsets to that we'll dig into, but I'll let each of our panelists kick off, as well as, generally, but even as specific, I think, to where your own company's positions would be quite interesting with respect to the outlook for white box and disaggregation. Joe, I'll start with you, and then Tim, you can chime in as well.
Great, thank you, Sterling. So with white box routers or cell site routers, you're essentially disaggregating the software from the hardware, and when doing that, you're able to scale that platform very easily, as opposed to purpose-built platforms, which typically have a year or more, a year plus of development time associated with them. So as you scale into greater bandwidth demands, greater capacities that are needed, as we've seen 4G to 5G, and then all the different applications within 5G. We went from 1 gig backhaul to 10 gig backhaul as typical in terms of 5G applications. And then there's the front haul applications associated with those as well, going from some number of gigabits to hundreds of gigabits of capacity that's needed. Scaling those platforms in an efficient way, of course, efficient as in minimizing the power, minimizing the footprint, but still providing that performance as in like 800 megabits per second or 800 gigabits per second, and up to a couple of terabits per second. This is easily performed with white box routers, given that you can use commercial off-the-shelf platforms made by a number of different manufacturers that have broad use in the industry. And through that use, you can then address all the different X-haul applications quite easily and scale that network quite easily from a 1 gigabit per second backhaul, front haul, mainly on a backhaul at 1 gig, up to 400 gig, using the same platforms, and these platforms using the latest technology. They're small. They're 1 and 2 RU in terms of footprint, and still able to achieve these very, very high capacity throughput capabilities. And then as you, maybe getting into the second part of your question, as you begin to develop these white box solutions, it leads to virtualization, which at some point in time you'll have the MEC, the DU, the CU, all virtualized and potentially all on the same platform, the same hardware platform that's partitioned to allow all these different types of applications running simultaneously. So it's a matter of having this high performance hardware and then running the different software applications that are separated through that disaggregation, which also enables that virtualization technique that will also give way to ultimately slicing, mainly soft slicing in this case.
So from Fujitsu's standpoint, you're obviously in favor of this. You're on a panel that's talking about it. You have product that does this, and you have, is it commercially shipping, and this is an active area of?
Just being made generally available now.
Okay.
There are other platforms in the industry that do similar type of aspect. So this is not new technology, white box technology in terms of cell site routers, but it is taking advantage of the latest in terms of the hardware technology, and then using proven software stacks running on that technology so that you can operate access aggregation, leaf spine, core, edge networking, all using the same building blocks to do that, just applying different software applications to the building blocks.
Yeah, to your point, this is not we've been following this. The data point I put up was from one of our surveys we did a while back at this point, but there was tremendous interest in this trend globally, and we've certainly seen movement. It doesn't always happen as operators expect, but it is something operators were telling us they want. So the question we're getting at then is, how far have we moved and towards reality? Tim, I'll let you weigh in as well here, and same set of questions: the outlook and to where where Juniper fits in.
Gosh, big subject. Okay. I may be slightly controversial with some of the things I'm saying here, but
That's good.
Hey, let's have some fun. So, okay, let's start. So, a show of hands. Who has, and we have vendors and providers here. So, as a show of hands, who has transport products that use Broadcom forwarding silicon in their portfolio or in their network? And just show of hands. No? Fujitsu is not using Broadcom. So for everyone else, yeah? I mean, you know, if you've got Silicon or Ericsson in your network, Ciena, it's all Broadcom, right? So what really is the difference between a white box, which, by the way, is using the same Broadcom forwarding silicon, and a vendor's own integrated product that's using the same Broadcom silicon? And the reality is, it's that little word I put in the middle there. It's integrated. That's really the only difference. There may be slight differences in time to market. I'm not saying that white box is quicker, because the time you've actually integrated the software on top of your white box, probably it's actually slower to market, not quicker than integrated products. So what is the difference? The difference is in the buying behavior. For some customers, they like the idea of white box because they think, okay, we can get the hardware cheaper. I can tell you now, I have a choice as a product manager for my portfolio whether to develop my own products internally or whether to use a white box for time to market because the hardware is already available. And pretty much every time, in fact, I can say every time so far, if I want the lowest cost, I have to do it myself. It means I have to do my own design, and that means the conversion cost the manufacturer charges me to build my product to offer it to the market is significantly less than if I buy from the same manufacturer their own product they've already designed. Why? Because they want to take some margin for themselves. And the reality is that the margin that we take and the margin that they want to take is exactly the same. The difference then comes that we as Juniper, and the same is true for Ericsson or Ciena or Cisco or many others doing integrated products, is that they then spend the time to integrate their software on top of this hardware and closely integrate it, and probably also adding a little bit of extras. Like if we look at our own product, we have our own timing hardware and timing software stack that we put as well, that you don't get on a white box. Little things that we do extra to differentiate from a pure white box. It doesn't mean that we cannot put our software on a white box, and indeed, we do that, not particularly, quite honestly, in the mobile aggregation space, but certainly other portfolios within Juniper, you'll see white box hardware used with our software. We do it in some cases. Here, where we feel there's a need to have very precise timing, some other features like security that we put that I'll talk about later, certain things we do our own designs and we feel that they are better. But ultimately, the forwarding is the same. It's the same chip. The power is the same. It's the same devices, right? The interface is the same. The hardware is the same. The only difference between white box and an integrated design is the integration. You do it yourself. And has that been successful in the market? I let you decide. And maybe someone from Ciena here can speak up about, or maybe AT&T if they're here as well. What was their experience in trying to do their own software that they now sold to Ciena? Why did they do that? Was it because they could not be successful? I don't know. It's not a question I can answer, but it's just saying we've seen people try to integrate themselves. It's not as easy as you think. Okay?
So you've definitely opened up quite a few topics. So let me see. I don't know if anyone wants to comment. That's wonderful. The disaggregation challenges, and I put a data point up. You have rightly observed that these challenges come up. The technology and the integration are both. We've got a comment question from here. If we can get a mic over.
Hi, Brett Chambers with IP Infusion. So obviously disaggregation is core to our business. And I agree with a lot of what you said, but I think ultimately what we see is flexibility. So as a traditional vendor, you might only have a few platforms, where for us as a NOS vendor, we port our software onto dozens of different platforms. So that provides our customers and our system integrator partners the ability to pick and choose the right platform for that specific use case. And a lot of times that's reflective of price and just overall fit. So, like you said, you may, when you analyze it, you may be apples to apples with the similar platform, but you may not have that specific platform for that use case that would fit that price point.
Hello? Yep. And that's a fair point, for sure. If you've got gaps in the portfolio, and I'm no different when I'm looking to complete my portfolios in as short a time as possible to have something for every piece in the network, then sometimes you're right. I may miss a certain piece of hardware, and therefore, like I said, looking to use a white box for time to market and then integrate the software on top of that, the same as you would integrate your software on top of a white box. It's just from a platform perspective, I agree, you need to have, really to be optimum in the network, you need every type of possible platform, and then with software, of course, integrated on that. So more varieties of hardware platform, I mean, varieties, not just different manufacturers, but varieties, definitely makes for more optimum design, because then you can truly pick the hardware specification that meets best that particular node's requirements. So definitely optimizing makes sense. That's an argument to have a wide variety. It's not necessarily an argument for white box per se, because you can implement that same variety with integrated. But I take your point. Definitely can be that you can have gaps in a particular vendor's portfolio that you can then fill maybe more easily with a white box. Yeah.
Thank you.
I would also, yeah. I would also say that, Tim, you make some very good points, but the point on pricing, I think is very different, mainly because of just economics in demand. Hardware used in white box cell site routers, for example, apply to so many different applications. Virtualizing server market in general, virtualizing the mech, virtualizing the RAN components, the active RAN components. This is where the volumes will basically drive, the costs down, because with a purpose-built platform, it's just that one purpose. You've developed it. You've developed it with the right cost structures, sure, but it's just being used for cell site routing, for example. Whereas in a white box cell site router, that same hardware is being used in multiple high-demand global applications that, are open, globally. Also, in terms of timing, it was another point that you had mentioned. These cell site routers have, or white box cell site routers, they have GNSS receivers built into them. They're fully integrated. You can directly connect antennas to them and run PTP through the network using them. So they also provide a highly synchronized network base for overall network, especially with 5G and nanosecond timing requirements.
And so that's not really a difference between integrated product and white box. It's exactly the same. It's what you're saying is basically, hey, there's hardware designs that you can reuse, let's say, in aggregation roles, for mobile front haul or backhaul, as well as in data center use cases. It's true. And we do the same for integrated products, right? It's the only difference between white box hardware and an integrated hardware is who's putting the software on. In one case, it's the same vendor as who's designing the hardware, and in the other case, it's just a different vendor. That's the only difference. Integrating GNSS in cell site routers or front haul, of course, and that's also available from integrated solutions. It's the same hardware, guys. It's not different hardware. The difference is purely down to who is integrating the software. the same vendor or a different vendor.
That's a
all.
model, yeah. Let me, and then we'll move to the next topic. I think we've got there's a disagreement in some of the views, but let me get definitely some audience comments and questions.
Yeah, I have a question with regards to interoperability between software and hardware. So this is a question for you, maybe in your experience, since you are doing disaggregation, in your experience, is that responsibility remains with the hardware vendor, software vendor, or do we pass it to the operators to do the interoperability testing between different software versions and hardware versions, and how do we manage the life cycle of the software and hardware?
Right. Great question. Pushing the integration to the carriers is basically the wrong course of action. They don't want to take that on. They have a carrier network to manage and maintain, and taking care of the individual elements, that's the responsibility of the vendors. And so, the vendor basically takes care of all of that. The full integration, as Tim was saying, in fact, that full integration. And it's not only, we're talking about white box routers, but it's not only the white box router, then there's the optics. And the optics, alone are almost 50% of the cost of the overall solution. And then there's variations on optics, and I think we're going to get into that.
That is the other major thing I want to hit
coming
for
up.
sure,
But
yeah.
there's all these variations, and integrating all of that, the optics, the software, the hardware, to have the right mix to address specific applications that the carriers have, is the flexibility that, in fact, my colleague over here was also mentioning, that white boxes give you.
Just to add to that, so we do have one product in the portfolio I look after, which the hardware comes from a different manufacturer, and the biggest challenge I have in terms of troubleshooting network problems from customers is on that product, simply because we don't have the deep insight on the hardware design that we have on our own products. And that is, again, another challenge when you're trying to do a white box. It's not you can't do it, and when we say disaggregated, ditto with optics, again, we try to qualify as many optics from as many different vendors as we can on our platforms. And when someone wants to use an unqualified optics, it'll probably work, but can we guarantee it hand on heart, or may there be issues? They're the challenges that come up with, again, when you're doing something that's not 100% understood from the software team, because it's not done in-house. And there's that communication between hardware and software and different teams. That's the piece that sometimes is missing. I'm not saying, and I hope you don't take away from me, that white box bad, integrated good. I'm just saying there's definitely additional challenges that come with white box, and people should be aware of them.
So we know, and I don't have it here because it's more of a U.S. event, but TIP has a map they put out, and it does have several dozen deployments globally of named operators that are interested in the disaggregated cell site gateway. It's a cell site router. So there are places where it is being adopted and deployed. If we look at the North American market, though, we know AT&T has been a major champion, even at past events that we've done here. Beyond AT&T in North America, are there other customers that are engaged buying white box for 5G? And maybe, I don't know, Joe or for each of you, Juniper, anybody else interested in beyond AT&T North America? Is it just nobody else, or you have interest, customers? And then same for Joe, and then we'll go to the next topic.
I think generally, globally, there's interest, right?
Yeah, absolutely right.
I think no doubt about that, and definitely people are looking at it. Some have started and then moved away from it, understanding the challenges as they got further into it. I think it's a very new area. I think it's an area where actually there's going to be people who have preferences. AT&T had a very strong preference from the beginning to go that route. Others will choose a different path. I think there's a market for both integrated and disaggregated white box solutions. It's not that we have to pick one or the other. I think they are just a little different in terms of what you get from the vendors. I think in terms of, to some of the questions that you had, in terms of performance and function, I don't really see there's a difference because we're using the same components. In terms of cost points, we're using the same components. It's all about where does the margin go. But ultimately, the underlying components, the underlying cost, power, etc., it's all the same.
All right, Joe, last word, and then we'll go to the next topic. unless there's a comment.
I would agree with Tim in that, it's a global market.
Yeah.
And in fact, with TIP, mainly in Europe, they've been following this for quite a while now. It's not really new over there. But in general, it's global market demand for white box routers.
Yeah, it is interesting though, that global map. I mean, outside of AT&T, there's not a lot of logos. Well, there's no other logos in the U.S., but globally, South America, as you say, all throughout Europe and Africa, there's quite a bit. So it's an interesting difference that we've seen here to date. Let me go to the pluggables, and there's a slide there, a bit of an eye chart. You guys can look at it as you wish, but for each of you, so this is an area of open. And maybe it has some impacts on disaggregation as it's kind of getting to some of the end goals without the full management and control kinds of decoupling that are required. But pluggables is a big trend in optics. There's an alliance that I know Ericsson is quite strong on for adapting pluggable requirements specific for 5G. Some of the stuff that came up even this morning is, back to Mark's comments about the heat profile. So there's a lot of interest in pluggables. They cross the board. Joe, I'll let you start, and then Tim, but maybe to frame this, of all the different pluggable opportunities that you see for 5G transport, where are you seeing the most interest and where are you putting the most investment? Joe, I'll start with the Fujitsu side, and then we'll go to Tim.
Where are we seeing the most investment, the most interest? That's a tough one because there really are so many different pluggable options that are available to address different applications. You have a list of some basics up there, but self-tuning optics, O-band optics, O-band at 25G, at 100G, used for LAN/WAN applications, which provide a much more economical way to do add drops in the optical layer than doing it at the IP layer. It's another set of applications, very useful and effective at the edge of the network, not so much at the core of the network for that particular type of application. So that would be yet another set of optics.
Joe, actually, the LAN/WAN, this came up, and I put this bullet on there from our earlier discussion. I didn't know anything about it. Maybe just even kind of give the audience of what exactly is that? 'Cause it was new to me. It may be new to others.
Sure. That's it's basically an IEEE standard, 802.3 standard, one of the variations in 802.3. And this is the ability to use O-band optics. O-band, if you're not familiar with it, is a subset of CWDM, but much, much narrower spectral widths in the 4 nanometer-ish, 4 to 5 nanometer range. So it allows for minimal dispersions over the path with having up to 100 gigabits per pluggable. There's also, at the lower end, there's 25 gigabit pluggables that are used in LAN/WAN, and that's used to make optical add drop capabilities, and at optical add drop is a lot more efficient, a lot more cost effective, especially in the access area, than doing it as an IP over WDM type of solution. Right. But that's just a couple. Yeah. There's also, I mentioned smart self-tuning optics, which allow plug-and-play operation, very fast deployment. If you're looking to deploy, for instance, a venue application where you only have a few days of setup time before it's actually showtime in a stadium, a sports arena, using self-tuning optics is absolutely an area that we have found most effective because it's fast deployment. You basically attach the optics to the fiber and they self-tune to available wavelengths on their own.
Would you say that's widely available, like a kind of a standard way that 5G would be deployed today, or is this more new concept?
You know, there's trade-offs in all of these. It's very popular in venue applications, small cell applications, but then in other applications it might be cost prohibitive. Because, you know, the high cost of the optics, having that automation integrated into it. It really depends on the applications and the economics of the applications where it's most effective.
All right. Tim, yeah.
That's a nice segue. I think if we look at the different optics on here, generally, you know, driving towards new technologies and new types of optics, we're always driven by trying to reduce the cost. You know, if we just, you know, you can go through this list, right? I mean, definitely if we, you know, starting at the top, I mean, BiDi for obvious reasons, right? Fiber limitations in the access network is common for many service providers, so bidirectional is paramount to keep the cost of the infrastructure down. 10 gig BiDi been very common for many years now. 25 gig was something we saw coming up probably the last year or so as a common demand. And also in the last year, we're starting to see 50 gig BiDi and 100 gig BiDi coming as an ask. So it's a market which continues. We want to get with just the single fiber to the gateways, you know, all of the bandwidth we need in both directions down that one fiber. And so the speeds are going up and the demand is going up. And yeah, we have to, fortunately, it's not too difficult with the BiDi optics to support these and to have backwards compatibility with the older routers, the older gateways and things. I think some of the optics on the list, particularly if you go down to things like, you know, ZR+, the XR, some of these are pretty high power. Some of the economics of those models, I'm still scratching my head on myself, I have to say. I mean, the XR, I mean, Juniper's, we're part of the XR forum. I'm interested to see how that plays out. I think operationally, the benefits are around TCO and how you do simple upgrades just by, you know, you've got your sub-channels at 25 gig, you've got a common 400 gig at the head end, and that ability to increase bandwidth from step by step. But then my head starts going to, okay, great, so I've got 16 remote sites and a common 400 gig site at the head end, but what happens when I just want to upgrade one of those sites from 25 gig to 50 gig? Now I have to move that channel onto another port at the head end. So operationally, I think there's still some stuff that we need to figure out, and cost points we need to figure out.
So your view there, is it more from what you see your end customers as service providers, or is it from you as an equipment company, how to build XR?
Both, right? So from an end customer point of view, ultimately, it's about cost, and it's about total cost, right? So it's about the power, it's about the operations, how simple can we make it, how can we minimize the things like fiber cost and things like that. So it's all about cost. From our perspective, you know, we see all of these new types of optics coming along. We have to make sure that the platforms that we're building today can not just accept today's optics, but are ready for those other optics without limitations, I should say, as well. I mean, that's the other challenge that you see for a lot of equipment manufacturers. You know, you had a product, it was ready for, let's say, 20 watt optics. Oh, now we have to do 25 watt. Okay, do we now have to, can we manage that? Can we manage that at the same operational temperatures as we had before? Can we put it in every port, or we now have to have special rules that say, okay, not in those ports, or if you put it in all the ports, you can't do this temperature. You see that in equipment manufacturers as they struggle to address the new optics and the new power levels at the same time as maintaining simpler operational practices. This is a challenge.
Right. I mean, I imagine that if the operators, enough of them are engaged, they're going to tell you what to do, and you'll have to figure it out.
And obviously, from a vendor perspective, yeah, can we do it with the product we have now, or is this a whole new product we're going to have to bring? Right. With you know, different form factor, different number of cages, etc. This is the challenges we have as an industry for sure. Yeah.
Do we have any comments, questions, anything around the optical pluggables?
Anything someone would like to see but doesn't see yet?
How many people know what the XR optics is? Just a show of hands. Are people very familiar with it? Not many, right? Yeah. So it's a, I don't know how to even describe it. It's a point to multi-point type of. It's taking a coherent optics and it's dividing into sub wavelengths. So it's kind of doing what used to be done on the packet level, but it's driving it down to the optics layer. It's clever, but it's very different. But I know Verizon is on the.
Yeah, exactly. Definitely, there's a lot
looking at it, right?
A lot of interest around it as an architecture, and certainly the claim is that operationally it simplifies things. But I think again, it's going to be coming down to costs overall, and showing that there's a benefit over the total life of the deployment as you upgrade, not just day one.
One of the, I don't want to spend too much time on this one, but as I'm thinking about why it came into the context of this event is operators have, you can use it over a PON infrastructure. Operators have a PON infrastructure, and they started looking at that and saying, well, we have all this fiber passive out there. What if we can also put these higher speed optics in and reach 5G backhaul? So that sparked the interest. Whether it can be done or not is, it's being looked at.
And again, it's very similar to the sort of drivers you see for BiDi.
Yeah.
It's about trying to optimize fiber infrastructure that's in the ground.
Before I go to the last topic, which is on automation, any thoughts, comments on the 100 gig, which is the newer, I mean, the 400 gig optics is pretty much too much capacity to Mark's comments this morning, 10 gig to the cell site, and you kind of aggregate, well, 100 gig sounds good there. There is new coherent 100 gig, which seems like it could solve some of that. Our survey, which we did here, which I'm showing, is showing operators looking at 100 gig coherent are very much looking at it for mobile applications, but it's new in this very small form factor type of deployment. For Juniper and Fujitsu, just curious what your views are at this fairly early stage. Maybe Joe, and then we'll.
Sure. So we have found just 100 gig coherent optics absolutely useful, and it also goes back to what you were mentioning about XR optics as well. Mm-hmm. So XR optics offer long distances using coherent technology for multiple sub-wavelengths, doing your add drops at the optical layer. Just like this LAN-WAN technology, this IEEE standard that's been out for some time, but without coherent technology. So it's much shorter distances, but the same type of add drop capabilities that are done on the optical level.
Yeah, I don't think there's a doubt about the use cases for 100 gig coherent. I mean, reality is we've had 100 gig, 200 gig coherent in this part of the network since, basically CFP2 was definitely a very popular deployment model. You see a lot of products leveraging that, including our own and pretty much from every other vendor as well. I think the difference here is that we see QSFP28, 100 gig coherent coming.
That's it.
And you're not going to see a big difference in cost point, right? The internal components are going to be somewhat similar, but obviously the form factor is smaller and it opens it up, therefore, to perhaps a wider range of products because of the form factor. I think for me, the interesting thing is going to be, when we can get iTemp compatible optics in that form factor.
Which is like outdoor temperature.
Yeah. So initially they're going to be, again, it's a much smaller module, so it's harder to cool. So initially they're going to be limited in the range, but you're going to get extended temp, but not full iTemp yet. But I'm sure that will come.
Yep, so. Absolutely. That's what we're seeing. Yeah, we are very short on time. If there's any last comments, questions from the audience, otherwise I don't want to keep us from lunch because we did promise time for networking. Good. We will close out here then. Thank you to our panelists.